We are Green Home NYC. Just a little spiel about us. We are a volunteer-run nonprofit organization whose mission is to promote energy efficiency and sustainability within the built environment. We have three main branches of our organization. We have the monthly forums, which is what we're doing today. We have the career panels also that happen on a monthly basis. And we also have site visits. The site visits are a bit on hold because of COVID, but usually we would go to, like a rooftop garden or a composting site. And luckily our forums and our careers are still going strong via Zoom. So first up, we have Scott Acker. He is an educator, speaking from the perspective of an architect. Scott Acker is a registered architect and professor of interior design at the New School and the University of Pennsylvania. He teaches architecture, history and theory, contract documents, and building systems integration for interior designers. Scott's topic talk will discuss past and present architectural approaches to sustainable indoor air quality, design fundamentals in particular now, and how we can push our designs to improve the invisible qualities of human comfort, air, and sound. Welcome, Scott. Let me pull up your.
Thank you, Danny.
Okay, ready.
Perfect. So I'm just adjusting my screen here. So it's an honor to be here and to give this talk on a short presentation on the history and design thinking of sustainable interiors from the point of view of air and sound. So the first slide, please. So the question is, what is human comfort? What are the major factors that play a role in our comfort, in our well-being? And what are these invisible forces that impact our physiology? There are three parts: radiation, humidity, and pollution. These are the three kind of aspects, invisible forces that impact our well-being. So we have a tall order as interior designers to create interiors that protect us from these factors. So where do we turn to in our thinking, our advanced thinking? This is 2020. So where do we turn to get those great thoughts? Next slide. Of course, Elon Musk with his Tesla. And what's kind of interesting about this, if you're familiar with this Tesla biohazard button on the car, when you press it, it activates a HEPA filter that filters with the ionizer. It's activated with the little electrical iodine, binds the particles, pollution, viruses together through a filter to purify clean air. So in the next slide, incredible advancement. You can see here that 2016 thinking is well positioned in this really devastating situation that's settled upon the Bay Area, the smoke that we see here. So you could be riding along in your Tesla, if you can afford one, and be purified, have purified air and kind of withstand this kind of environment. Really amazing interior when you think about it, but it's, highly privileged and not everyone can afford it. But, it kind of like shows you where we are, 2020, and the image next to it, we're not too far off from what Venus looks like. That's what Venus looked like back in 1982. The Soviets took a picture on the surface of Venus, this highly toxic environment. And the next slide, you can take a look. But that's not to stop us. I think that we are really, dedicated to our technologies. And this is a fantasy project. This is Cloud's Architecture Office back in 2016, made a fantasy proposal, but it's quite serious. They were commissioned by NASA to look at what's called a Venus garden tower. So this tower essentially acts like a HEPA filter in the skies, kind of spirals up into the clouds, filtering this toxic cloud that humans can't exist in. But we see in the recent news that there could be life there. But this is this kind of idea of the exterior world we can take control over. We can, with technology, we can create an interior world that's superior to the exterior world, no matter where we are, either whether it's on Earth or on Venus. Next slide. But as you know, it's not just the exterior environment, the COVID virus situation. So humans contribute to the environment, whether we're outside or inside. We exhale water vapors that are in the air. We exhale carbon dioxide into the environment that affects our surroundings. And a really amazing manual that LTL Architects recently published, this manual on physical distancing for COVID-19. Please check it out. I listed the website down there. And a really amazing manual where they looked at interior spaces, distancing, how to rearrange the interiors, and following the COVID CDC guidelines. The next slide. One of the conclusions, it's about 100 pages, but one of the kind of amazing, really interesting conclusions that they found was already kind of documented, well documented by ASHRAE, which is the American Society for Heating and Ventilation Engineers. And they, looked at the aspect of ventilation in the building, natural ventilation, and then also existing systems, existing HVAC systems. How can you improve it? And then when you have a new mechanical system, how can you better control that with the technology, better calibrate that? So really amazing findings by LTL Architects. Please check out that manual. It's really important, current topical research. The next slide. However, they were not the first ones to look at that. Early modern architects, believe it or not, were faced with a situation that's current, not too dissimilar to what we're facing with COVID. They were dealing with a difficult health problem at the time in the 1940s, tuberculosis, and part of what they thought would improve the interiors was bringing people to the outside environment, bringing people to sunlight and air. They thought that that would be what could heal people with tuberculosis. That was their attitude. So Alvar Aalto, in his Poema Sanctorum, designed using these really long bars of a hospital to increase natural ventilation. And then part of the hospital was even outside, where they laid out the patients. Nurses would attend to the patients while they were just outside looking at this kind of amazing finished landscape, beautiful exterior air quality. And you could see that in some of Aalto's kind of initial sketches. The other thing that's kind of interesting, the sensibility of not just bringing the technology of the time into the interiors, but real sensibility in this noiseless wash basin. So Aalto was even concerned with like the splashing of water, not to disrupt somebody who is trying to recover or not doing well. So the splashing, the shape of the bowl was really important. So let's next slide, please. So these passive systems, this is an important part of interior planning is how do you bring air from the outside naturally inside. Passive systems is a term in sustainability. It's using natural ventilation to cool a space without the means of electricity. So looking at where windows are placing, optimizing that. And we currently use simulation, even though these are techniques that are ancient in the way that we understand how air moves, hot air rises, and cross ventilation. But we still use these computer simulations to simulate how that is happening on a building. Next slide, please. Active systems, on the other hand, are mechanical systems that deliver conditioned air using electricity. And if we look at our the seminal historian who brought this thinking to interior architecture and architecture as a discipline, Rainer Baum, a California mechanical engineer turned into architectural critic. He is the founder of systems thinking, ecological building systems integration, and he really challenged architects in the way that we think about human comfort even to today, in ways in which that impacts ourselves. Next slide, please. And in Banham's seminal article, he wrote, "A home is not a house." He was really questioning architects' use of form, and he leveled his criticism on architecture and architects in general and saying, what is the form of your house? And the image to the left is really what your house is all about. So what is that form? And a little tongue in cheek, he was proposing on the right is the form of just a bubble. I mean, it could just be this plastic bubble you enter in. That's what else do you need? You have your comfort. Next slide. So that's, a lot of architects, really took that to heart, but also realized the tongue in cheek. Louis Kahn was kind of reciprocal influence between Kahn and Banham. Kahn really was one of the first, really interesting if you're fascinated with systems integration into interiors and architecture. Kahn was one that was really trying to work through that problem using his concept of service and serve. This is the Exeter Library, a beautiful interior library space. And the systems are fully integrated within the form, vertical ducts, horizontal ducts, and celebrated. It's not something that you see, it's something you see at some moments, so it's concealed, but then revealed in other places. The next slide. So where are we today in terms of that kind of integration? We're looking at really pushing the mechanical system ductwork down, making it more efficient. So on the left, you see the ductwork of a, just pretty much a ubiquitous system of ductwork. And on the right, a high velocity system. So looking at ways to take that duct system that takes a lot of space in the interiors and pushing it down. So we're trying to improve the system, shrink it down, make it more efficient, high velocity. Next slide. And we're also using current computer-aided design, BIM technology, to calibrate humidity levels, air change in a space, and in making it very specific to a certain function of the space. An air change is the term which mechanical engineers size their system. Air change means taking a cubic square foot of air and making new fresh air within an hour of time in that space. So you can imagine the space in the room that you're in currently now, and imagine these 1 cubic cubes in the space. That has to be changed out every hour, depending on what kind of space type you're in. So you see that chart here. And that changes based on how many people are in the space or what other kind of equipments. And so that's kind of where we are in terms of mechanical systems and thinking of that. Next slide, please. So the mechanical systems they put a lot of pressure on an architecture, so positive pressure, so the air is being pushed out of the building. Negative pressure, you may have heard this in the news, like these negative pressure rooms. We need negative pressure rooms for hospitals. A lot of hospitals use that. That's basically pushing the air in and or sucking the air out, directly out. And that helps to control the vapors that come out of when we speak and other people. So that helps to contain that. You can turn your own room into a negative pressure room by taking a big fan and just putting it right next to a window and just blowing it out. And so it's pulling that air, it's creating a negative pressure in that room. So if you're interested in turning your own house into a negative pressure, that's the way that you do that. Next slide. So it's really a balance, right? As interior designers, we're balancing natural ventilation with highly tuned mechanical systems, the need to bring in fresh air or conditioned air versus all these other kind of factors that LTL Architects is, highlighting here in terms of the viral buildup in the environment. Next slide. But we do live in all sorts of buildings that have varying ages of mechanical systems. And because we are in a positive pressure space in most cases with conditioned air, you can be breathing in this dust or air, bad air from crawl spaces. Next slide. So the way that you can handle that is obviously to test it. So it's called sick building syndrome. And that's the propagation of this kind of pollen or mold buildup. If your system is not balanced, HVAC system, have too much humidity, over 60%, then you can start to have mold spores that grow in there that can be blown around in the room. So that leads to sick building. How to improve that? MERV filters is one way to do that, and there's a range of it from 6 to 13. And we're very much familiar in the news on these kinds of mask and protection. They have varying densities of woven fabric. So a MERV 13 is one of the highly dense woven material that helps to block out the virus. You can also zap it, the virus or other mold bacteria, with a certain UV light within the duct system, before it's delivered. So some people do use that as a way to improve existing mechanical systems. You can also clean out the ducts as well. So you can scrub out the mold and start fresh. But even starting fresh, you probably want to institute some of these new measures, filters, UV lights, so on and so forth. Next slide. Right, so this is kind of like where we're going. On the left, you see this kind of highly tuned, censored, oriented space. It's a little fantasy-like, but we're not too far off from that. But with this kind of topic of air quality and control, we cannot forget about sound. So next slide, please. Right, so taking that room on the left, highly tuned for humidity and well-being of air quality, that room, that picture of that room, if we considered it untreated with any kind of material, which that was, if you clapped your hands, you would hear an echo coming back to you at 2.9 reverberation time. And if we look at this acceptable chart for sound quality, it doesn't meet any of those things. Not even a music room, not even a space in a cathedral or organ kind of place. It's too much echo. So you have to, a rule of thumb to improve that space, that high-tech space that we just saw in the previous slide, 20% of that room surface has to have absorptive material to make a change on the echo of that space. So it's a really exciting kind of proposition for interior designers when it comes to sound. Next slide. So what are when you talk about material and sound, it's essentially three types. A material can be a reflector, which reflects the sound in the space, an absorber, meaning that sound hits it and absorbs, or a diffuser, where sound hits it and scatters. A diffuser is something to be used to keep a space lively. So if that was a question you're having, when would you use a diffuser? Most likely in a space like a restaurant where you want to have it feel lively, but you don't want it to be an echo chamber. So usually diffusing that sound, having this kind of texture on the wall really helps. Next slide. Well, what's interesting to me, and I'm fascinated with mostly with sound, is the geometry. And you can design and shape your space to improve that sound. And the way that sound works, just a kind of a 101, is the way that sound hits a surface, the angle that it comes in is mirrored to the angle of reflection. Think of like a mirror and someone shining a light on it. You can adjust that plane to bounce that light into another part of the space. So light is reflected, sound is reflective off material. Sound also passes through material as well, affecting other kind of spaces. So you can shape mostly the ceiling of a room to really have an impact on the quality of sound. Next slide, please. And so let's turn back to Alvar Aalto, 1935. He designed the Viipuri Library and used geometry in this long, narrow space to shape the ceiling using reflective material. So that you can see here in that slide to the right, these are his drawings. and the musician playing in this long, narrow library, the ceiling would carry that sound quality throughout the space for someone back in the back end of the room, hearing that same kind of great quality that someone in the front end of the room would hear. Next slide, please. And so, you know, we're still using that way of thinking today. Brady Peters in 2018 designed an installation using parametric geometry to analyze sound and to form find this installation where one part of the form would dampen the sound, the other part would reflect it. Really amazing kind of research that Brady Peters is looking into. Next slide. And also with that kind of thinking of designing material that could be 3D printed, looking, analyzing the sound. This would be a diffusing type of wall because you see the pockets of space, and really kind of interesting trajectory in which we can take control of the sound quality in a space and to shape it and to improve the interior atmosphere and improve the human comfort. Next slide. So I'd like to conclude with just a series of material examples and really innovative materials if you're interested in sound quality in your spaces. This Australian gypboard is a smooth ceiling. It helps to, the angles would help to absorb some of the sound being reflected in this library computer lab. So really interesting faceted ceiling and optimal acoustic qualities. Next slide. And again, when it comes to sound, I'm really passionate about this and what it can do for our interiors and environment. You could take just this kind of ubiquitous gypsum board that we see everywhere, which is horrible for acoustics. It really makes an echo chamber. If you just punch a hole in it, it becomes a diffuser. And so these are examples where interior architects have used basic materials of gypsum board, even metal, and wood acts the same as a way to absorb sound just by punching holes. You can have a lot of fun with the patterns and the quality that you can create in that kind of interior environment. Next slide. And really interesting kind of synergies between air and sound. This amazing reindeer moss, which helps to improve sound and also improve the humidity in an interior. So it's just an amazing kind of sound absorber that you wouldn't necessarily think of being on the interior of a space. So it's an amazing kind of product. And the last slide for the presentation. And I wanted to just conclude with this kind of really interesting, one of the biggest problems of our time, and even with COVID, doesn't make it any less easy, is restaurant spaces. So in dealing with sound in restaurant spaces, one of the master problems that we deal with, this is a really interesting solution in London where the use of this geometry to isolate a conversation, but also keeping the openness of the liveliness of the space is just the shape of it. And then the applying of this really amazing kind of felt material to help dampen the sound. So that concludes my short history of design thinking from air and sound. Thank you so much.
Thank you, Scott. I have one question. Anyone can put a question in the chat box and we can review it at the Q&A towards the end. But just one quick question. I saw that a lot of the sound absorptive materials have like those little dots in them, like you were talking about. Could that possibly contribute to the sick building syndrome that you were talking about how there's like these little spores, these little molds, or these, just dust?
It could. I think that part of what I wanted to introduce with this lecture, going from the Tesla to the space to passive to active system, there's like pros and cons to doing anything. And I think once you focus on one, there are problems that lead to another. So it's really trying to find that balance. So to answer your question about those, the holes in the material, that would require some maintenance because it would build up dust. There's no doubt about it. Like over time, dust would build up into it. So, you know, I think if you're proposing that kind of material, it's always something to kind of work through. What is the maintenance plan that you propose? Because I think as interior designers, we also have like a responsibility to help the homeowner or the client with a sustainable cleaning plan that makes sense for what their needs are. And so, it's as simple as like vacuuming. You would essentially vacuum the wall just like you would vacuum the floor. A lot of the manufacturers would say, but improving the filter is also another way to kind of minimize the dust. But one of the interesting things with building is as soon as you build something, it starts to decay, and that's just kind of like the way that things are, the reality of things. So if you didn't use a space and no one's in there, it just accumulates dust. I think the exterior environment, the world just kind of takes it over. And so, yeah, that's a very good question. And, how do you strike that balance for the human comfort?
Right. All right, thank you. If anyone has any questions for Scott, feel free to put it in the chat box and we can get to it at the Q&A session. Now we have our second guest. Our second guest is Kalli. Let me read her bio. Okay, Kalli Solby is a senior analyst at the International Well Building Institute. As a member of the IWBI commercial team, Kalli leads the global business development efforts for the multifamily residential sector and uses her technical expertise to guide over 34 million square feet of real estate through the WELL certification journey. Currently, Kalli is working with multifamily residential developers to make health and wellness a top priority in light of the COVID-19 crisis. Welcome, Kalli.
Thanks, Jenny. I appreciate that. While we're getting those slides pulled up, just want to say thank you, Scott, so much for that lecture. I think you captured about 4 years of architecture school in about 20 minutes. So big smiles all around, and thank you for that. But as Jenny mentioned, I'm here to talk about the WELL Building Standard. Next slide, please. My name is Kalli Solby, and I work as a member of the commercial team, coaching projects through the certification process, which I'll tell you a little bit more about in a few slides. But I also lead the multifamily residential sector business development efforts, and additionally the affordable housing sector. I'm definitely looking forward to the days where we can be having these conversations in person again, but for the time being, thanks everyone for being here virtually. Next slide. I know 15 minutes goes awfully quickly, so I'm just going to dive right into talking about the Healthy Buildings movement and about the WELL Building Standard more specifically, and how we pay careful attention to air and material quality of buildings, and how we celebrate and certify that. Next, please. Before we get into the details of the standard, I just want to remind everyone that WELL, or the WELL Building Standard, is a standard and certification program designed directly for people. And so we have the word building in our name as the International WELL Building Institute, but we really just use buildings as a vessel or a vehicle to impact the health of people. And many of the best practices that Scott kind of just walked us through, that UVGI to make sure the cooling coils are clean, MERV filters to pay careful attention to our air quality, acoustic comfort, those are all packaged up in a way that makes it easy for developers and practitioners to track and pursue best practices within their buildings. Next, please. So I'm sure you've all seen this statistic before, and if you haven't, I'm sorry to scare you, but we spend approximately 90% of our time indoors, and I'd argue in today's current health crisis, that's even more. So this means that our health actually begins at home, at work, and in all of those spaces where we spend time indoors. Next, please. For a really long time, people thought that genes and your genetics or your medical care were the biggest determinants of our state of health. But the most recent data from the CDC actually concludes that our physical and social environments are playing the biggest role in the determinants of our health. So the good news about this is, as developers and practitioners or HR professionals, we all have a role to play in supporting people living their healthiest and happiest lives. Next, please. So now that you have a little bit of background about WELL and IWBI, we can dive right into the details of the standard a little bit more. Next, please. So the WELL Building Certification Program actually works in conjunction with other green building rating systems. So rather than being competitive with the sustainability industry, we work actually to complement it by optimizing building performance for human health and environmental health. Next, please. In order to release the first version of the WELL Building Standard, IWBI undertook a rigorous peer-reviewed process to develop the standard. So for 6 years, we had scientists, doctors, building practitioners all working together to contribute to the WELL Building Standard. Next, please. As you can see here on the slide, wellness strategies in the WELL Building Standard are very comprehensive. We have 10 different wellness concepts that touch on everything from providing occupants with high quality light to the design of a staircase to motivate people to move throughout the day to supporting mental health of occupants in a variety of features. So for today's purpose, we will take a deep dive into the air and materials concept. Next, please. So we'll talk about air a little bit. The experience that we're seeing with air through the WELL Building Standard, basically the air concept aims to ensure high levels of indoor air quality through a building's lifetime through many diverse strategies. So not only do we look at design elements or parts of the built structure that help eliminate or reduce source pollution, we also look at operational strategies and human behavior intervention. So one of the main ways we do this is by setting guidelines for filtration, installment, and maintenance. I will pause here to honor the maintenance component of the WELL Building Standard just to illustrate that creating healthy buildings is an ongoing venture. So it's not enough just to install a filter, but it's important to maintain and evaluate the functionality of that filter on an ongoing basis to ensure that the building continues to function at a high level. We also demand high ventilation rates. So as Scott kind of mentioned, ASHRAE, we take ASHRAE one step further, and for building certification through WELL, you need to be exceeding those ASHRAE requirements by 30%. So really going above and beyond to pay careful attention to this. We also pay careful attention to source separation, so that any activity in the building that's emitting VOCs or volatile organic compounds or particulate matter, for instance, electronics rooms, printing centers, bathrooms, we want those basically as far away from people as possible so that we can give them high quality air. Next slide, please. The biggest issue we see with air, kind of as surfaced by the Global Burden of Disease study, is that household air pollution actually was rated as the 10th most important cause of ill health in the entire world's population. So out of the infinite number of things that could possibly contribute to poor health in the entire world, poor air quality was actually in the top 10. Next slide, please. So as frightening as that is, that does give us a great opportunity to actually kind of mitigate or prevent about 12.7, so almost 13% of deaths can be prevented by following these best practices in air quality. And so we kind of see this from the perspective of designers and practitioners. You know, we have a really big role to play in the health and wellness of the globe. Next slide, please. Talking a little bit more about the materials concept in the WELL building standard, this materials concept really aims to reduce human exposure, whether direct or through environmental contamination, to chemicals that might impact health during the construction, remodeling, or operation of the building. And so we do this through a variety of measures. A few I'll point out that tend to be a little bit less talked about. The first one being waste management. So paying careful attention to how we store and dispose of waste. That can impact our air quality. Site remediation, so paying really careful attention to what we might be unearthing during construction or demolition. It's really important to consider kind of legacy materials that are in a building that are unearthed during this disruptive process. And the last thing I'll mention is just long-term emission control. So we're thinking carefully about how materials going into our buildings are off-gassing. Are we selecting products that are prone to bioaccumulation? And hopefully the answer is no, but WELL provides guidelines to really follow and make sure that these considerations are at the forefront of the priorities of our building developers. Next slide, please. The materials concept also advances two strategies for selecting building materials and products. One of them is to increase literacy on materials by promoting ingredient disclosure, whereas the second is to promote the assessment and optimization of product composition in order to really minimize the impact to human and environmental health. So both strategies aim to bridge gaps in the supply chain, supporting innovation in green chemistry and advancing market transformation towards healthier and more sustainable products. So just so you all have a bit of an understanding of why we're kind of trying to bridge the gap between data about materials. An estimated 95% of chemicals that are used in construction actually lack sufficient health data on health impacts. So 95% of the materials that are going into your building have actually been studied to have health impacts. And so there's only a tiny, meager 5% where we actually have data to kind of educate our occupants. And so one of our goals here at WELL is to just increase transparency and really demand that manufacturers kind of dig into the details of this so that we can create healthier worlds. Next slide, please. And so just kind of reiterating the impact that we can make through material selection is aiming to reduce the risk of exposure and really support innovation in chemistry and advance market transformation. Next slide, please. So now that we've kind of talked about 2 of the 10 concepts in the WELL building standard, I'll just give you a little sample of kind of how the building standard is pursued. But essentially within those 10 concepts that I talked about earlier, there are features that are preconditions and there are features that are optimizations. So basically projects can earn different certification levels by earning points from those optimizations. In order to be a WELL certified building, you must meet all of the preconditions. So we've outlined about 124, I think, off the top of my head, best practices for building design and operation. And so there's 24 that you have to meet. And then we have a whole host of features that you can use as optimizations towards earning a level of certification. Next slide, please. And so lastly, I'll just really talk about the value of better buildings. And so we can jump right into the next slide where I'll basically just share some notable quotes from the World Green Building Council. Their Doing Right by People and Planet report, which actually featured a variety of WELL certified projects. So just to kind of highlight a few and talk about the drastic improvements that paying careful attention to these features can do. ASID is a platinum certified project here in the United States, and since being certified, they've actually reported that absenteeism has decreased by 19%, and sick time has also decreased by 16%. So we see really huge improvements to kind of the way people are feeling in their spaces and how that is reflected into productivity. Next, please. And then moving into the residential sector more specifically, I really just want to point out how WELL brings benefits to both a residence and the physical property itself. So when the wellness movement started in real estate many years ago, wellness for residents was kind of disguised by fancy and expensive technology. But over the past 5 or 6 years, WELL has been working to kind of dismantle this narrative of healthy for the wealthy. So WELL provides a cost-effective way for residents to live in a building that takes a holistic approach, a comprehensive approach to health. And in so doing, residents have improved energy, they sleep better, they're more productive, and they want to continue living in the spaces that make them feel healthy. And then the final thing I'll mention about the properties is receiving the WELL certification mark is really a leading way to earn a market differentiation and brand equity. Last few slides here. IWBI and Enterprise Green Communities have teamed up actually to create a streamlined criteria for affordable housing, blending planetary and human health strategies into a single framework. So the Enterprise and IWBI organizations spent more than a year integrating wellness features into Enterprise Green Communities criteria, resulting really in a product and plaque that will for the first time kind of represent a dual pathway towards human and planetary health. And then the final slide here, just kind of highlighting some key metrics to demonstrate, the growth that we've seen over the years. We have over 300 certified buildings across the world, over 4,200 registered projects, and well over 10,000 WELL APs that are engaged in our accredited professional program. And so the last slide here is just a link to our website. And so feel free to kind of navigate there and investigate some of our other best practices. Thank you, everyone.
Great, thank you so much, Kalli. I do have one question for you. You provided us a statistic that was, I believe, like reduced 16% in absenteeism. All right. Is that because of like air quality and people are really feeling like they get less sick in those buildings? Or is it because it's just like a really beautifully designed building and people just like want to be there?
That's a great question, Danny. And we have some of this data in granular detail, and some of it is just kind of amassed through a variety of surveys that projects are asked to kind of distribute to their teams. And so what we found is it's actually a combination of both. And so there's a positive correlation between the built environment that you're spending and how sick you are getting. So if you are feeling happier, your immune system is better, you're taking less sick days. So it's kind of this positive feedback loop that we see, benefiting the overall health and happiness and productivity.
Great. All right. If anyone else has any more questions for Kalli, please leave it in the chat box, and we'll get it to in the Q&A section. Okay. Next we have Mikhail. Okay. Mikhail Davis is Director of Technical Sustainability at Interface, a world-leading modular flooring company with a fully integrated collection of hard and soft flooring. Interface's mission, Climate Take Back, invites industry to commit to making a profit in a way that is restorative to the planet and creates a climate fit for life. Mikhail is responsible for advancing Interface's mission in the Americas by building internal leadership capacity, facilitating strategic alignment of efforts, and creating external partnerships that shift the marketplace towards sustainability. An expert in sustainable materials, he leads Interface product transparency efforts in the Americas and was lead author and editor of the Radical Industrialist column at greenbiz.com for 2 years. He also chaired the Lead Materials and Resources Technical Advisory Group for the U.S. Green Building Council. Welcome, Mikhail.
Thanks, everyone. I did not bring slides for a change because it makes me talk too much. So you'll have to remember a few key acronyms. I did bring a prop, though. This is Poppy. She is not accredited through anything, but she does have a fine example of the first thing we should think about when we're thinking about VOC emissions from products, which is a nose. a much better nose than we have. So her VOC detector is much more potent than anything we have. But what I'm going to walk through today is just some basic rules of thumb and things to look for. If you're looking for, when you are in the process of acquiring products, of the sort, we make flooring to put in a space, that obviously is one of the things that will impact your indoor air quality. Now, the thing I will go on to expand on is also one of the things that will impact your outdoor air quality, because the emissions that went into the environment, including those climate changing greenhouse gas emissions of all of the stuff that we buy and put in our spaces, is something we haven't been really keeping track of. We're trying to make our buildings more efficient and use less energy, and LEED and other standards have been doing a good job of. We haven't necessarily been keeping track of all those emissions that went to create the stuff that goes in our buildings. Now, the emissions we'll start with are those emissions that literally come out of the stuff, our volatile organic compounds that Kalli was talking about. So that's the first thing. Kind of makes sense to start there for our indoor air quality. Because there's a lot of things about how we make stuff and what we put in our buildings that impact health. But the stuff that we know will be an issue is the stuff that literally off-gases directly from the products we put in the space. So the first thing I would note is everyone has a VOC detector. They're not as potent as Poppy's, but if you smell something that smells off, you should investigate. That's a VOC. Now, the thing to keep in mind, though, is that not every VOC that might be irritating or even toxic has a strong smell, and not every VOC that has a strong smell is toxic. So, for instance, fresh baked bread is emitting quite a lot of VOCs. That's what you're smelling. Not toxic, but it is VOC. And then there's quite a few VOCs that are fairly non-odorous, but actually you wouldn't want to be breathing a lot of, which is why we have to go to using tests for these things. And we'll talk a bit about the key relevant standards that Well and other people use for testing products. And what they do is basically say, these are the chemicals that matter, and you can't emit them over a certain threshold for each chemical. So they kind of bake in a lot of science. I'll talk about that in just a minute. So the first thing is pay attention to the smells. I mean, some of the smells that we can smell, including stuff that people bring in, like perfumes, really are sensitizers, and people can react badly to them. They actually, it's part of why you do air testing in a space, not just say, oh, well, we have all low VOC products. Individually, that's fine. But if someone wears a lot of perfume or someone used a cleaner in the space, that can also put fumes into the air and damage your indoor air quality. So there's always user error, in addition to getting manufacturers to do as much as they can to have lower emitting things that we're putting into a space. So first, trust your nose. Second, pay attention to those liquid applied products, whether it be an adhesive or a paint. There's still anything that's liquid applied has what's called VOC content, which is different than a VOC emission. VOC emissions are unintentional. That's just stuff that happens to off gas. VOC content, when you see something as zero VOC content, that does not mean it doesn't emit VOCs. It means when you have VOCs, so think about a paint. You put it on the wall as a liquid, and by design, part of it, in order to cure that paint dry, is supposed to emit into the air. It literally has VOCs, volatile organic compounds, put into the mix of the paint that are designed to come out as it cures and hardens. So zero VOC content is a great place to start when you're looking at anything liquid applied, because there are ways to do that. Mostly they're water-based adhesives or water-based paints that don't require the emission of adhesives or the emission of VOCs in order to cure, in order to dry. A lot of the adhesives we use are actually releasable adhesives, so they never dry completely, which is part of why they're so low VOC. So that's the first thing. And that's, of course, built into LEED. And there's these certain thresholds that say, for each product category, for instance, you have to have less than 50 gallons per liter of VOC content. That is a really non-protective bar. I mean, it's something. But we really could, a lot of categories, you really can be looking for zero VOC content, adhesives, paints. We should be able to get that. The next thing, once you get into those unintentional, those VOC emissions, those are not really supposed to be in there. They just happen to come in there. It could be that you've received a product that hasn't finished curing, like it has a coating on it, or it has a certain layer of it that is still working out its chemistry because it just got manufactured. And it's having chemical reactions and giving off stuff into the air. The way you deal with that typically in a lead or a well building is you require all of those materials, especially interiors materials that are going to be in our airspace, to get a chamber test, which is literally you take the product or a sample of the product and put it in a chamber and measure what comes off it in a laboratory setting. And so there's a testing protocol that was developed by the California Department of Public Health that stipulates exactly how this test has to be performed, what specific VOCs, because they're looking at specific problematic ones, not the fresh baked bread ones, but the petrochemical, damage your health above a certain level ones. So they've curated for you what are the chemicals to be concerned about and how much of it should be concerning to you, and then you basically get a pass fail on this test, which is now you could call it the lead test or the well test. It's the same test. It's that same California test. There's also by industry brands of the test or by certifier. So the thing to know about this is you're looking for one that's LEED or well compliant or compliant with CDPH. Now for carpet, it's Green Label Plus, that's the branding. For resilient flooring, it's Floor Score. And all these different categories, furniture has its own, a lot of furniture uses GreenGuard or GreenGuard Gold is what you need. GreenGuard is actually not compliant with CDPH, but GreenGuard Gold, which is their next higher level, kind of goes above and beyond even CDPH. So there's a lot of branding. There's MAS, and then there's ChemClear. They're all the same testing protocol, but they all have different branding on them. And occasionally they have little tweaks, like carpet wants you to test for 2 other things, but that is a great baseline. Now, the thing I will say is for people, and I'm the person that get a customer that has like multiple chemical sensitivity gets directed to me usually. And what I tell them is this test is not designed for you. It is not sufficiently protective for a person who has an unusual medical condition. And so I'm not necessarily even going to recommend a product that passes Green Label Plus or Floor Score for you, because those are based on, now it's a California test, so it is very protective. They assume really conservative estimates of trying to protect, but it doesn't protect a person that has a condition like multiple chemical sensitivity. So even within that, you need to go and think below that and look for, can we get stuff that's as close to 0 VOC emissions? Because the CDPH test is just a low VOC test. But there are things that are inherently non-emitting, like stone. There's other things where you can get closer to 0 VOC. Like we have one installation system that's a liquid-based adhesive that you spread on the floor and then you attach the flooring. That is 0 VOC content. It is low VOC, but it is not 0 VOC emission. Now, if we install, like in Kalli's office, if we install with the little connector tabs, which is literally just a one-sided, square about this big, that is nearly 0 VOC emissions for the installation system because it's a little piece of tape essentially. And you just connect the corners of the squares or rectangles of flooring to each other, and then it's a floating floor. That is pretty near 0 VOC emissions. But the fact is that products made out of plastics and petrochemicals and coatings, which are a lot of things, even you think you're getting wood, it's probably coated in plastic. They all can off-gas. They all often have some curing process, either chemically or using heat or both. And sometimes that process isn't finished when it first arrives. And that's what you get with these sort of new furniture smell or new carpet smell. And that's why you do these tests. So you design the chemistry and the product design to have as little of that as possible. It's still not usually 0. So the other thing I will say on that is that for the ongoing, there are these ongoing issues. One of them I would say is for maintenance, is that you do need to maintain these things. You need to think about cleanability. As Scott was saying, if you put in a particular finish, you need to already have a plan for how you're going to clean it. There was a great, in well version 1, there was a credit called cleanable environments. And one of the things I like that it actually said, you can't permanently attach carpet to the floor, which of course we don't do anyway. We use releasable adhesives or the little tabs that are actually sticky side up, and so they're not attached to the floor at all. Because you inherently, at a certain point, you can't really clean carpet that's glued or tacked to the floor. It's gonna start holding dust that never quite comes out of it. Now, if you can take it up and periodically do, yeah. I haven't seen it in well version 2, but again, I haven't read the whole new standard. So I just know it was feature 28 in the old one.
Maybe packaged a little differently, but cleaning protocol still in there.
Oh yeah, I mean, without the one specifically about broadloom carpet, which we love because we don't make broadloom carpet, and most of our competitors do, but
Somewhere over there on the floor.
but it really goes across. You need to think about, okay, I'm putting down this, because people sometimes will say, oh, well, carpet, isn't that bad for allergies? I'm like, if you don't clean it, it is. Because carpet actually takes allergens out of the air and puts them into where the base of the fiber. If you look at the carpet, which we do, we all do, we look at it, looks clean because all the dirt sunk into the pile. Now, if it was a hard surface floor, oh, hard surface floors are better for allergies. That's because you clean them because you can see the dirt. If you clean your soft surface floor remotely as frequently as you clean your hard surface floor, it's actually better for allergies. Because if all the allergens are floating around on your hard surface floor as opposed to captured, they're nicely captured, waiting for you to vacuum them. If you don't vacuum them, they eventually do get hard to get out. So again, you have to have, if you're just not going to vacuum, yeah, don't have carpet. It'll be bad for allergies if you let it get dirty for long enough. And similarly, I mean, it is good if you can wet clean your carpet at least once a year. That'll really get out some of the deeper stuff. The thing that we sell, I mean, if we're talking about homes, we sell it tile by tile, and we sell it all to be connected with the flooring. But you can literally take a tile that gets stained and put it in the sink. So that's one way to do it. You know, in commercial settings, we recommend that you actually go get the wet cleaning machine and do a deeper clean to sort of rinse out the carpet regularly. We also put in a preservative in there that essentially makes it so if you don't clean it and stuff sits there forever, it still won't grow mold that becomes one with your carpet. And that's an important thing for people who are sensitive to mold and for people that don't clean the carpet. Because you literally, and we've seen everything bad that can happen to carpet. Customers say, your carpet failed. And we're like, we send us a sample and we're like, did you ever clean this? Yes, it's growing mold. It in fact encapsulated the preservative, you let it, and then grew mold on top of the layer of dirt. Anyway, so you have all of the carpet horror stories, but essentially you need to think about, and so the other longer term thing, as Kalli alluded to, is you can have chemistry in interior finishes that it's not volatile. The molecules are too big. If they got into the air, they would sink to the floor because they're not these lightweight molecules that become airborne at room temperature. But you do have other things that over time will come out of a product. They're usually called semi-volatile organic compounds, SVOCs. And a lot of the things that are in some of those other well standards where they're calling out certain kinds of flame retardants, certain kinds of softeners used in plastics. What's the other? The other one, and this is a big one, is because it's used on the surfaces of things, are stain repellents, where you've got those fluorinated stain repellents. They don't come off immediately, but they do over time, especially on high touch surfaces. And so we, over 10 years ago, removed all of these fluorinated stain repellents from the surface of, it's traditionally used, it's that wonderful thing where they dump the blue Kool-Aid on the white carpet and it just beads up and stands there. It's magic. Turns out it might be black magic, according to green chemists I'm talking to, because that chemistry comes off of textiles and carpet and never goes away. It literally never degrades in the environment, for thousands of years. So you do have to pay attention to certain of those things. I think the first priority is the VOCs and making sure it's not literally coming out of the product into the air. But the stuff that ends up in the dust over time is worth looking at, especially for these kind of high priority chemicals of concern, like would be listed in a standard like WELL. And then finally, I will just say that and it is painfully clear to us in California, where I'm sitting today, that the biggest concern for indoor air quality becomes outdoor air quality if we do nothing about climate change. We will be in the same situation, and going back to some of what Scott talked about, you already have it due to industrial pollution in other areas. And in Shanghai, the #1 way to get good indoor air quality is to keep the outdoor air out. And any number of big cities surrounded by industrial areas, that is true. But now it's becoming true in California for anywhere that's remotely close to a wildland interface where we could have a fire, which we seem to have anywhere within a 4-month range. In the last 3 years in a row, we've had the worst fires ever. So it becomes something, if we're concerned about indoor air, we have to be concerned about climate, which means we need to start paying attention to all of the stuff, all of those manufactured things that we put in spaces. What did it take to produce them? Was it a high carbon footprint? Was it a lot of emissions if you really look back at it? Was it lower? Was it, it also, do we have to think about just the amount of stuff? Can we use it again? Can we take something and repurpose it? Can we buy something that's easy to maintain so it lasts longer? Can we buy something that's more durable? All of these things will prevent us from having to go out and buy it again, which of course necessitates more emissions. So we've been working on that. We're actually at the point we're going to be in about a month releasing the first carbon negative carpet tile, which actually we so changed what went into it and the processes to make it that it actually took more carbon out of the atmosphere, more of those greenhouse gas causing emissions, to make it than when we put into the atmosphere to make it. Because it's not like there weren't emissions. We still trucked stuff around, but it's just we used materials that, for instance, were made from plants that took carbon out of the atmosphere. And once you do all the life cycle assessment calculation, we ended up on a negative number for certain products. And so we're really charting that course to try to challenge. The architecture industry is really just starting to keep score on what they call those embodied carbon emissions, but we don't see them. They're not literally coming off the product, but they happen before we even finish building out the building in a manufacturer's factory somewhere or in our supply chain somewhere. We used plastic. And that required someone to extract oil, refine oil, turn oil into petrochemicals, turn petrochemicals into plastic, all of which put emissions into the atmosphere at each step of that. So for instance, the big things we need to start, getting out of virgin metals, virgin plastics, virgin petrochemicals, all of these things which necessarily require us to put more emissions into the atmosphere. We tend to focus on renewable energy, which is super important. But unless we have renewable energy powering every stage of how we make stuff, it's not as important. We have a stuff problem more than we have an energy problem. And until we get, so we power our whole factory on renewable energy, but now we're working to get our suppliers, the people that make the yarn that goes into the carpet. We don't make the yarn. So we can say, well, not our problem. But now we're working on getting our yarn supplier on renewable energy, getting them to use only recycled content. So there's a lot of cool work done on this. There's starting to be products you can get that are carbon neutral, where people have at least bought shares in some carbon reducing project equal to their carbon footprint. But it has to be something we start asking for, just like we asked for low VOC testing. We're like, hey, can I get that carbon neutral? Because ultimately our indoor air quality is linked to our outdoor air quality, which is linked to our climate.
Okay, great. Thank you so much, Mikhail. I think that was a really important note for us to end on. I think one big question for me is, I think I've seen some statistics about how climate change is increasing the likelihood of respiratory diseases. And do you have any data on that? Or I can open it up to the whole group if someone can speak to that.
There's a lot of great data on that from both the World Health Organization, the Harvard School of Public Health. There's a slide we always use, if I had my slides, that is a CDC slide that starts with, in the middle, the climate change stuff, the rising sea level, the increasing average temperatures, and then it radiates out into stuff that are all public health problems. So it's like, oh, that sounds like we need to build a seawall, or it sounds like the government should do something about it. It radiates out into very everyday things like increases in respiratory ailments. increases in allergies, asthma, spread of certain kinds of diseases, you know. So it takes connecting the dots, but if you ask any of these organizations, the CDC, even now, even now when the CDC is overwhelmed with the pandemic, the #1 threat to public health in the 21st century is climate change, because it affects everything. Even when we don't have wildfires, having more of these very hot days and more sunny days makes air pollution worse, which is, if you ask the American Lung Association or any of those, air pollution drives a huge number of deaths from respiratory, and heart disease every year. So having something that across the board makes air pollution worse is something to be concerned about from a public health perspective.
Totally. Scott, Kalli, did you want to speak to that?
Yeah, I'm interested in the kind of memory of materials and how like third-degree smoke can embed itself in a material and have an impact on people well beyond when the person who's the active smoker is gone. I think that there's also like this kind of the memory of a material and the delay of off-gassing that I think that we should also be mindful of, and try to institute some sort of like policies about that, because I think that's where a lot of these issues come to play. It's just political, right? It's the knowledge is out there. I think someone in the chat was wondering, where do we get this information on, what's a VOC, what's acceptable. The EPA, ASHRAE, they do outline, what's acceptable. Like every material off gases something. So they try to kind of give us range of what could be harmful and what not. And I think it's fluid, it's always changing. But I think it's, because long-term effects. Third-degree smoke is one of them that's not well understood, but it will be. But it's a political thing. It's a policy and politics is where all this stuff plays out. And we have great organizations like Well and Lead that really kind of push these things to make what is a great kind of program to then become something everybody uses. But we got to get the policies straightened out.
I think one thing that I started thinking about when Mikhail was mentioning asthma and respiratory illnesses, what are some other symptoms of like VOC exposure or sick building syndrome? It's for everyone.
I can start, and then Scott and Mikhail, feel free to add color, but a few of the key kind of health impacts that we see from research about sick building syndrome and about poor air quality, obviously asthma as being the leading cause or leading effect really. We also see kind of drowsiness, nausea, headaches, and these are all a reflection of poor air quality. So we see these kind of acute health problems that are compounding over time that really have larger long-term effects. So if you have a headache because you're not sleeping, by kind of transitive property of equality, if you will, that impact of the air is now impacting your sleep, which is now impacting the way your organs are functioning, which is kind of bringing in these bigger health problems. So from the wellness perspective and from our research, that's what we're seeing. Scott, Mikhail, I'm sure you see other kind of impacts in your scope of work as well.
Yeah, I mean, air quality is also interesting because there's a lot of study now on cognitive function. And basically poor air quality, and the Harvard and a bunch of other collaborators have worked on this, have shown that even CO2 concentrations, which is just sort of not enough, air changes in a space where you're not getting enough. So CO2 is just, we're breathing out and we're not bringing in enough, fresh air. Just that level, let alone the VOCs of these sort of potentially, more irritating and hazardous things. Just having elevated CO concentrations above a certain level, we start to get really stupid. start to be able to not solve basic problems that we solved easily with better air. So it's really interesting. They're starting to see some thresholds. Of course, then the connection is, so if it's 900 something parts per million is the concentration that makes us really stupid, and the outdoor air keeps creeping up, it's now nearly 450, we're halfway to really stupid all the time. And it takes less, bad air management to get us to 900 something. So that's where the indoor air quality starts to connect with outdoor air quality. It's half, it's not close. It's not like we're walking down the street stupider at this point. But it's really interesting to note that it's the same, component of the air that we're concerned about that's trapping heat and is a real problem at 400, parts per million outside. It becomes a problem for our brains functioning properly at about double that.
I think we can all relate to that. Yeah, I think I've definitely been in like classrooms or offices, and it just gets so stuffy in there and you just can't concentrate.
It's very intuitive.
Yeah, I think that's what's interesting about all these respiratory and like climate change related illnesses is that it is very intuitive. Sort of like what you were saying about, if you can smell it, it's probably like going to set off an alarm for you. And that's leading me to a question that someone from our audience asked. By the way, if anyone has any questions, please feel free to put it in the Zoom chat. Gal asked, I would be curious to learn more about diagnostic tools beyond dogs, which is a great idea, to identify VOC overload and other contaminants. Like, what do you do if you don't have a sensor like in your house?
Sorry, I missed that, Danny. What if you don't have a what?
Like a VOC sensor or a way to test your indoor air quality.
I think kind of one of the biggest things is really monitoring the outdoor air quality. So what environment are you surrounding yourself with? And we have some great public available data to kind of educate people on that. And so obviously, with operable windows and kind of the leaky buildings that we have here in New York, at least, the kind of outdoor air quality has a big impact on the indoor air quality. So I would kind of charge you with the task of looking that up and seeing how your air quality is holding up and kind of taking interventions from there.
Mm-hmm. Yeah, that leads us to Liza's question. Can each speaker recommend their top 3 suggestions everyone can do to help improve indoor air quality and sound quality at home? That's also now office, gym, school, study, everything. Everything's at home. So Kalli, you started it off by saying check the outdoor air quality advisories. I think I definitely feel little asthma symptoms when the air quality is not great. Does anyone else have any other suggestions?
I
can also.
Go ahead, sorry.
Go ahead, Scott. No, that's okay. I'll pass the building standard around. We kind of outlined top strategies from our perspective, so I'm happy to pass that along to Danny, who can kind of distribute that. But Scott, sorry about that.
Oh no, yeah, it's no problem. Sorry to interrupt. Yeah, it's a very good question. I think that sound quality during this home office virtual world that we're in is a problem because for whatever reason, when I have multiple Zoom calls with other people in the room, my call picks up the people in the other rooms more clearly than it does for me. So yeah, I think that's, and then also, I think the well-being of being in a nice quiet space for your interiors in your home, like trying to find a way to bring in more absorptive material and have it on the wall. You always hear, laying out the carpet, but, a lot of people are, not really into that, but that carpet only does so much. I think it's really about the walls. You can improve the wall materials that you have and don't do what I have, which is just gypsum board. I'd like to show an example of when I lecture of what not to do. to try to bring in some fabric, some curtains, some absorptive materials to help to improve the quality. And then, I guess some other ways about air quality, trusting your senses. I think the biggest problem with air quality, the natural ventilation coming in, but also the rise of humidity. So anything that's above 60% humidity starts to have mold growth. And if you feel like your space is damp, you most likely probably have like mold growing, mold spores. There's no doubt about it. So investing in a dehumidifier, I think is one way to extract the humidity out, and they're really cheap. You can buy them off of Amazon, and a little small one if you have a small unit, and that'll help to extract some of the humidity out. So, but it's trying to find that balance, because once you extract too much moisture, then your skin dries out and it's not so comfortable. So it's a balance. It's a difficult problem, but it's a fun problem to have.
The other tool I would recommend you have at home, I think dehumidifier is a great suggestion. I live in a fairly humid place, and my son has a dust mite allergy when they tend to thrive in humidity. Have a vacuum with a HEPA filter.
It's a great one, yeah.
Because otherwise your vacuum might just be sort of shooting out these smaller allergens out the back of the vacuum and redistributing them into the air.
Exactly.
And Mikhail, you shared these two great resources to check air quality, purpleair.com and eric.com. Everyone should get a chance to look at those sites. I think that's going to be very important.
We're checking them all the time in California now, so.
Yeah, I bet.
The other thing I would say is look for, I think modular, and there are modular wall coverings, but also obviously we make modular carpet. For this time where we're trying to set up Zoom classrooms or chat rooms or something in places we don't necessarily mean to have them forever, if you can have something that you can put up for now, whether on the floor or the wall, and take down easily, very important. As our houses now, each room has to have multiple purposes. So look at flor.com for if you need to buy like a temporary, area rug. But I think there's also a lot of interesting things, as Scott said, you can put on the wall. I always hope someday we'll buy one of those companies, because there's some cool acoustic finishes you can put on the wall that you can rearrange and make modules with. And we did some of them in our headquarters. It was fun to see someone do for the wall what we can do for the floor.
Exactly.
So have wall coverings and then wash them often, right?
Right.
Yeah, I mean, ideally, that is the challenge with all these things, is you want to look for washability anywhere you can. But also,
I think we should all buy more dogs, and if we just have tons of dogs running around everywhere, then their sniffers will kind of, guide us to the best air quality.
I think everyone in the world has a golden doodle now, so I think that's all taken care of.
Yeah. All right, we have one more question from the audience. It says, just one thing that's been on my mind regarding low VOC materials. I work in an architecture firm where we do incorporate low VOC materials. Do you think it would be beneficial for firms to talk to the developers and project owners about this? I guess in the hopes that they will see the benefits of their future projects. Kalli is nodding her head.
I mean, definitely, especially the problem for materials and getting to materials of a certain quality is the ownership structure of the projects. If they're just meaning to flip them quickly, that's the hardest. It's the hardest to get them to invest in sort of the higher quality commercial materials. There's low VOC everything available. It might not be the cheapest thing available on the market. So there's a lot of work being done on home free as one of the efforts to try to get some of the lower priced building materials to not be the exception to the fact that, oh, everything's low VOC. Oh, unless you're building affordable housing, or some of these other things, because it becomes, certainly a social justice issue at that point, where, there's no phthalates in any vinyl flooring anymore. Ooh, unless you're buying the really, really cheap stuff.
And kind of going off that, Mikhail, I think one of the things I mentioned earlier was kind of sparking innovation and creating competition in the marketplace. And so that's one thing we're trying to do kind of transiently as well is get developers and firms to demand these types of materials more frequently, so that if a manufacturer is, you know, now being demanded that that's the only type of material they want, it'll really spark competition. And so it'll drive down the price as the demand goes up, because everybody's going to have to start making it, and somebody's going to have to do it cheaper to kind of draw in business from other producers. And so I think that's actually one of the best ways we can impact the market, is by just talking about it and increasing education and awareness.
And what that looks like in the supply chain is suddenly no one wants to buy from the factory that's producing the high VOC version. So they transition that factory over to the one that makes the low VOC version. And then suddenly it gets cheaper because there's twice as much low VOC being made.
I think that's a good point. With COVID, I think people will be more cognizant of indoor air quality and respiratory illnesses. I know listening to this conversation.
Oh, I'll have to say one more thing about that.
Go ahead. Yeah.
There's so much hype going on about antimicrobials with COVID right now. Don't believe the hype. You don't need to buy stuff that has impregnated antimicrobials in surfaces and all that. None of it, other than really high copper content surfaces, which is only usable on a few things, none of it is proven to do anything against viruses. We run a microbiology lab that tests stuff all day and for a lot of other companies. And there's a lot of good preservatives that increase the durability of stuff and maybe can keep your stuff from hosting mold or something. But in terms of, don't count on a secret ingredient to kill COVID in an interior material. I can tell you right now, it is not a thing, and there's a lot of hype. Similarly, on cleaning products, COVID is really easy to kill. An encapsulated virus is the easiest type of pathogen to kill. You don't need some crazy toxic spray to kill all the COVID. You need to have frequent cleaning. You can use hydrogen peroxide-based cleaners, which degrade into water and oxygen. We're getting this question a lot from customers, and we essentially steer them toward the hydrogen peroxide-based cleaners, which all completely kill COVID. They're on the EPA's list and everything, and they're not toxic. But man, there is a lot of hype, and it can really damage your indoor air quality if you're spraying, you know, some of these quaternary ammonium compounds, super potent asthmagen. It's in a lot of the stuff people are spraying for COVID. We can really do a lot of damage to public health in service of public health if we do it wrong.
Yeah, that's a really important note. I think that we could probably talk for another hour, but I think we're at time. This has been a really great conversation. I feel like I understand more like why my breathing has been terrible, and it's definitely climate change. And it's definitely the sprays that I've been using in my house. So I really thank you guys, all the speakers, for joining us. This has been a really nice conversation.
It's my pleasure. Thank you for the invitation.
Absolutely. Thanks, everyone.
Thank you so much.
Happy Wednesday.
Thanks.
Take
Be
care.
safe and healthy, everyone.